Alright, still on differential equation, let's look at forms in which differential equation can exist. A differential equation can be non-linear differential equation, and a differential equation can also be a linear differential equation. Alright, remember in the previous lesson we talked about a differential equation as being ordinary differential equation or partial differential equation. Whether ordinary differential equation or partial differential equation, either of them could be linear or non-linear. How do we check linearity of a differential equation? Let's start with the non-linear type of differential equation. How do we examine a differential equation being non-linear? There are things you look at for. When you see any of these forms in a differential equation, it implies that that differential equation is non-linear. Number one, if you have a differential equation and in it exponential function, the exponential function in that differential equation contains the dependent variable y, or it carries differential variable, a dependent variable y, like exponential y, exponential 2y, exponential x, and the y is also included, etc. So any differential equation that contains exponential function carrying to the dependent variable, which in this case is y, then you say that differential equation is non-linear. Two way of knowing a non-linear differential equation: when the dependent variable y is a coefficient of the derivative, or it is multiplying the derivative if y is multiplying its own derivative, dy dx, okay, or is a coefficient of the y dx, is non-linear, or this can be written as y times y prime. You know, y prime we said earlier means dy dx, or you have it as y prime prime times y etc. Then you say this, the differential equation where you have this is they're said to be non-linear. Number three, when the differential equation contains power of the dependent variable or power of the derivatives, okay, it is non-linear. For example, if you have the differential equation, the dependent variable y is related to a power other than 1, let's say power y power 2, y power 3, because y is the dependent variable, then that differential equation is non-linear. Also, if the derivative of y, say dy dx or y prime, is also carrying a power, let's say power 3, then that differential equation is non-linear. So if you have also, let's say the second derivative of y with respect to x is carrying a power other than 1, let's say power 4, etc., then that differential equation is non-linear. Okay, so here we have y dependent variable to a power greater than 1, or the derivative, any of the derivatives of y, okay, carrying a power above 1, then we say wherever they are contained, their equation is non-linear. Then number 4, if the trigonometrical function, say sine function, okay, contains a y, carries a y, say sine y, then cos y, tan y, then you have sine xy, cos xy, and so on and so forth, then that differential equation is non-linear because y is a dependent variable. All right, it's not supposed to be contained in the sine, cosine, tangent function. All right, so it's, if it's found in the differential equation, we say that differential equation is non-linear. So these are the basic features you look out for to tell if a differential equation is linear or non-linear. Otherwise, if these are not contained in that equation, then we say that differential equation is a linear differential equation. All right, to summarize it, when these are not found and similar patterns are not found in the differential equation, then we can say that differential equation is linear. So we are using the test of nonlinear differential equation to tell when the differential equation is linear. So if condition 1 to 4 and similar pattern above here now are not in the differential equation, then we say it is what? A linear differential equation. For example, if I have y prime plus xy plus x squared y equal to e power x. So notice here that this is y prime and the power is 1. This is xy. This is independent variable multiplying a dependent variable. This is independent, dependent, exponential. This is carrying independence. So you see that none of these properties are found here. So therefore, this is a linear differential equation. Okay? All right, so that's how we tell. Suppose we now have something like this: sine x, then y prime plus xy equal to exponential y. Now look at this. This is a sine function. It contains independent variable. That's fine. This derivative of y, it has a power of 1. This is a product of y and independent variable. That's fine. But here, exponential is carrying a dependent variable. So because of the presence of this on this equation, we can say that the entire equation here is non-linear. Why this is a linear differential equation? This is the much we can take on this lesson. Subsequently, we keep progressing. Thank you so much for watching this video.